Ladies and gentlemen, please welcome our science track session chairs, Gregory Lesinski and Anwar Lapitz.
All right, good morning, everyone, and thank you for coming to this science track session. We're very pleased to introduce an exciting lineup of speakers, and the first presentation will be from Dr. Guido Carpino, who is a distinguished academic researcher at Sapienza University of Rome, specializing in the intersection of cancer biology and histopathology. His work primarily focuses on the role of progenitor cells in medicine, as well as the complex pathology of liver diseases, including hepatocellular carcinoma. His expertise spans a variety of areas, and he was previously affiliated with Health Sciences University and Foro Italiano University of Rome. He remains a leading voice in understanding the cellular mechanisms of liver-related malignancies. So, Dr. Carpino, I'll turn it over to you.
Thank you for presentation, and I'm very proud to be here. So I would also like to thank the organizing committee to invite me. This presentation, the topic of this presentation is about the experience of ESCA about the Histology Registry, but the first part of the presentation is about the role of histology in cancer, especially in the cholangiocarcinoma, because I think that is somehow understudied as okay, I don't know how it works. Okay. So when we look at the histology of a tumor, the histology of the tumor is really important because tells us about the anatomy of the organs from which the tumors will arise. But also, if you look at this image, the histology could also tell us about the cell of origin and the histology and the tissue of origin. This is very important and very clear in some tumors. So if we look at the example of the lung cancer, it's very clear that the histology subtype of lung cancer is different based on the anatomy of the tumor and the bronchi from which it develops. For instance, the tumor arising from proximal bronchi are more similar to the one in airways, while the tumor arising from distal part of the lung, they are very different. So there's a clear anatomical and histological classification in lung cancer, and this is very important for the taxonomy of the tumor, because the classification by anatomy and by histology could tell us about different tumor subtype, which is really important for a precision medicine approach, because when we want to develop a biomarker, one of the most important things is also to have a finer taxa to study and to be involved, or at least to be studied for the specific biomarker. So this is very clear in several tumors, such as the lung cancer, but also the breast cancer. Also, it's important to notice that the histology of the tumor is strictly correlated with the mutation profile and the genetic alteration. Again, this is very important to know why the specific mutation is linked to a specific histology subtype, because sometimes the same mutation could give different or divergent cancer subtype, or sometimes the same mutation could give rise to convergent cancer subtype. So the morphology could tell us a lot about mutational profile. This is why some studies in the past used the histological images to predict by AI the specific mutation landscape in a tumor. Also, when the tumor develops in different stage, it could change not only its histological aspect, but also the mutational profile and then the molecular one. When we look at the cholangiocarcinoma, we are used to subdivide it in different anatomical subtypes. In particular, we are very familiar with this image in which we use the term biliary tract cancer to underline all tumor arising from all portion of the biliary tree. But using this term, we are actually merging tumors arising from different organs, because now we know that gallbladder is we know that gallbladder is a distinct organ, and also the tumor arising from gallbladder are somehow treated differentially from cholangiocarcinoma. But also in cholangiocarcinoma, intrahepatic, perihilar, and distal are tumor arising from different organs, because perihilar and distal cholangio came from extrahepatic biliary tree, but the intrahepatic cholangiocarcinoma is actually a liver tumor. If we look at intrahepatic cholangiocarcinoma, it arises from all the portion of the biliary tree within the liver. That means that also it derives from the segmental duct that are really proximal with respect to perihilar. In fact, the histology of the intrahepatic cholangio is very heterogeneous, and now we know that we have two major histological subtypes. One is the large bile duct subtype, which is actually linked to tumor arising in segmental proximal duct, while the small bile duct intrahepatic cholangio arise from distal and smaller branches of the biliary tree. This is just not a morphological classification, but we are not used to do such differences. Actually, we are more used to skip the histological classification and go through the molecular classification. So when we look at the morphology classification, we can see that perihilar and distal cholangio are really homogeneous, and this is expected because they derive from the extrahepatic biliary tree, which is, as I told you, a separate organ. When we look at the intrahepatic cholangio, the mutational profile is very different and very heterogeneous. Actually, the mutational profile is not a good way to classify cholangiocarcinoma, because as we know, only a minority of people have a druggable oncogenic mutation, so a lot of people were excluded from this classification. But why we look at the morphology, we don't look at the morphology classification before look at the molecular classification? I think it's a matter of timing, because the molecular classification came first, then a consensus on the histology subtyping of intrahepatic cholangio, because the histology subtyping of cholangio is only published in 2019 by the World Health Organization, and also nowadays the consensus and among experts recommend to subclassify intrahepatic cholangio small versus large bile duct, but this recommendation is weak with a low level of evidence. So there's a lot to do. This is a recent paper which is in the press in Journal of Hepatology, in which they look at several tumors, cholangiocarcinoma, from different countries. They collect mutation data from more than 5,000 of patients, and they look at differences regional tumors. So they saw that there are no differences in extrahepatic cholangio between Western and Eastern country, but there are two main subtypes of cancer in Western and Eastern country when they look at intrahepatic cholangio. And the differences into this cluster is mainly due to a different histotype of the tumors, with the large bile duct type really more frequent in the Eastern country, while the small bile duct type is more frequent in the Western one. So they they state at the end of their manuscript that the mutational profile is strictly linked to the tissue of origin, and this should be really taken in account. So if we just look at the mutational profile in intrahepatic cholangio, we see a very heterogeneous tumor, but if we divide the cholangiocarcinoma in the two, intrahepatic cholangiocarcinoma in the two histological subtype, we have quite homogeneous tumor with IDH and FGFR2 mutation mainly present in the small bile duct type, while we have KRAS mutation enriched in large bile duct tumors. But where are the pitfalls? The first pitfalls is present in this table. It seems to be complicated, but this is present in the supplementary material of the paper I cited before. If we look at the method of categorization of the histology of cholangiocarcinoma, you can see that there's no single way to classify small and large intrahepatic cholangiocarcinoma. So what we miss at this time is a consensus on the way of characterize and distinguish small versus large and the histology profile of intrahepatic cholangiocarcinoma. There are some studies, if you look at this table, that use RNA-seq, so the transcriptomic profile, to classify an histological feature. This is not a nonsense, but I don't understand why. So, which is in this context the experience of the ENSCA. We decided in 2016 to start to collect cases from European countries. So we set up a collaborative network, the ENSCA, and we decided to collect not only clinical data but also histology samples. As you know, the clinical data are the basis of a huge effort by the group of Jesus Banales, and now there's not a clinical, an ESCA clinical registry, but actual global clinical registry. So this was very impressive for me. I take care about the histology registry, and I try to push other centers to send me sample to be included in such effort, and I would like to thank people who are working on this and helping me in building of this histology registry, because we think that having a series of connected registry is very important. Also, the international collaboration is key in this phase. Now we have a cohort of 300, nearly 300 cases, but most of important, I focus to have more European countries involved. So the number of samples could be easily arised, but I prefer to arise the number of countries involved. All the slides or the samples are digital now, so I can access to them by my laptop just right now, and all people in the world could do this. And we didn't not only stain for easy or basic marker, but we use a large number of immunohistochemistry marker to depict not only the histo-morphology of the tumor, but also several cellular aspects, such as the fibroblast within the tumor, the macrophages, and microvascular invasion, and so on. So we have at least 10 different stains for each patient, so you can simply understand that we have a lot of material in the histology registry. The registry was built for international collaboration, so it's open to anyone who want to collaborate and who want to use the data. We have done in this time preliminary analysis of some histological stain, just to have a depict of what we have in the registry. And first, we have divided the tumors based on the anatomy and the histology aspect. And as you know, in the upper right corner, the first data that we had was very frustrating because we thought that small and sorry, in the bottom right. We thought that small bile duct type and large bile duct type tumors would have different prognosis, but we did not have such results. Then we look at another marker that we have in the registry, which is a simple stain for mucin, the PAS stain, and we have another surprise because we did not expect, but not all large bile duct type are actually PAS positive and express a lot of mucin. Why this is surprising for us? Because the large bile duct type should be similar to the extrahepatic cholangiocarcinoma. But we use this phenotype to individuate a histological subtype based on the large bile duct morphology and the mucin expression, and this subtype is actually very aggressive with a very bad prognosis with respect to all the other tumor and a similar prognosis with respect to the peri-hilar. So we identify this histological subtype, and also we try to look in a validation court and external court this is confirmed, and as you can see again, large versus small subtyping is not sufficient to have a different prognosis, but if we look at the positivity to mucin, we have again a different prognostic aspect, which is also independent from other parameters such as the stage of the tumor, perineural invasion, and microvascular invasion. So considering also the small number of tumor, this is a very good results that we had. But the histology registry is actually connected with a radiological registry. So this is the way we want to work with these registries. So we try to find method to identify such histological aspect by radiomics, and as you can see, we develop a radiomic profile and radiomic tool to look at different histotype, and again we were able to have a good way to individuate by radiomics this aggressive tumor subtype, and also we did this by analyzing the serological profile and individuate serological marker that are able to distinguish the specific histological subtype. Now we are working on another tool in the context of histology registry, which is the spatial molecular analysis, which give a lot of information regarding the pathogenesis of the tumor, because we can choose some area in the tumor and also in the surrounding tissue. We can also select specific cell population, and then we have the molecular profile from all these selected sub-region. Now we are working on the so-called whole transcriptome atlas. This is a panel of the nanostring technology that allow us to have the full transcriptome of selected region. And now we are segmented cells for the as tumor cells, the immunocells infiltration, and also the stromal cells. So we have 3 segments that we are separately collected, and our target is to have 60 cases. Now we already processed 15, but of these 15 cases, we not only have selected just one region of interest, more than one, and also we have tried to select other particular phase of the tumor, such as we selected the perineural invaded nerve. We also selected some tertiary lymphoid structure with and without neoplastic cells inside, and also all the surrounding tissue, so interlobular bile duct in the liver and hepatocyte. So this slide is not updated because we complete a collection last week, so we have more than this. The number of the ROI region of interest that you can see. So although we have only 15 cases, we have a lot of region of interest that can be used also now for collaborative effort or for study. So just to conclude, I have two main conclusions. The first one is on the histology of cholangiocarcinoma, and my suggestion is not to skip it, but to try to do what has been done for other tumors like lung cancer or breast cancer. So to have a classification which take in account the anatomy and the cell of origin, the histologic classification, and then the molecular classification. This is very important for make an heterogeneous tumor divided in a more homogeneous subtype and try to study the single subtype. The other conclusion is about our platform, because I think that this is a work not for just us, but it's a work for the community, or at least this is how we think about that. So we have a large case series with histological classification and a lot of marker within the tissue for each component. We also have blank slides if there's need of some other stains. We have CT scans, so we can do correlation with CT and radiological images. So this is a platform open for any study. So I hope that someone would collaborate or include samples and patient, or asking for collaboration for a specific research topic. So I would like to thank all the people that are working on developing this resource. So thank you very much.
This is great. We have time for just a couple quick questions. Really, just to kick things off, was curious if you could. So, congratulations! It's really a tremendous resource. It'll do a lot of good. And can you just briefly comment on the regulatory aspects that you had to do to get this up and running and available for collaboration?
Yeah, this is a very important aspect, because for all samples we have a MTA with the institution. So this is very clear that we have to face in the past a lot of issue, but now we have an MTA that is shared with the other institution, and also for sure we have all the ethical committee approved in Sapienza for the cases, and also the institution should have the ethical approval. So it's something that we decide to do at the first. As a first step. So this is also why we have had a lot of struggle to obtain samples and to have cases in the registry. But now it's a resource. So sometimes we use it as a sort of other tools for researcher. Maybe if you have if you want to confirm some analysis on external cord, this could be used as external cord, but also with the molecular profile special level, this could be used for a lot of study, I think.
Congratulations. I think this is an amazing resource you have. I have also one question regarding the clinical information. Are these primarily surgical resected specimen, or are these biopsies before treatment? I mean, yes.
Okay, this is the first question that I have had, because I realized that nobody will send me blank slide from biopsies, because the material is so scarce. So we focus on resected cholangiocarcinoma. But for instance, when we look at the serological profile of pus positive large bile duct subtype in the case series, in the clinical case series, we included also resected and unresected patients, and it works well. Actually, one of the my goal is to go also on biopsy, so unresected patient, because now digital histology is used in a lot of institutions. So I think that we can, for resection, collect blank slides. Why? Because it's better that immunohistochemistry is done in the same center. So we do all the work also for the immunohistochemistry. But now with the digital scan, we can include, and I'll try in the next future to include also unresected patient and biopsy. I have one small cohort, but around 20 cases in Rome, and I will ask also for other collaboration. So this is also a field of collaboration. Sorry for the long reply.
All right, well, thank you very much. We'll move on to the next speaker.
Thank you.
Thank you very much, Guido.